In the last section, we set the type and the grid for our full field model. Now, we'll set up the initial data for the model. To import the maps, we'll go to the Grid panel, where all geologic parameters are set. Notice that when we look at these parameters, they're all set to constant. This was fine for the single well model, but we want maps in our full field model, so we'll specify that maps will be used for each parameter. To actually import the maps, we must open the apprentice file where the maps were stored. Notice that we see the maps that are available in Merlin and those that are in the apprentice file. These may or may not have the same name or be in the same order. To import them, we simply match them up and import them. Notice that Merlin specifies KY and KZ maps, while these are not available in the apprentice file. We could import the X permeability into these parameters and use it, or we can specify them in Merlin itself. Now if we look at the parameters, we'll see that we have maps for each of them. Depth, gross thickness, porosity, while we imported a map for Kx, we did not import a map for Kz. If we had directional permeability, we would want a different map for Ky and Kx. In this case, however, we'll use the same map for Ky that we had in Kx. Also, we didn't bring in a map for Kz. In this case, as is usual, we don't have a map for vertical permeability. So we'll simply specify that vertical permeability is 10% of horizontal permeability. To do this, we'll specify Kz as being equal to Kx. We'll then multiply the entire map by 0.1. The maps developed in Apprentice have now been incorporated into our full field model. But if you recall, the single well model that we built had a gas cap, an oil column, and an underlying aquifer. Obviously, we cannot accurately model such a system with a single layer. So let's subdivide our layer into multiple layers. We'll split the selected layer into as many layers as we need. In this case, we'll specify 5 layers. When Merlin divides the layer, it divides all aspects of the layer. So the gross thickness was split into 5 equal layers for the old layer. Net thickness was also split into 5 layers. Merlin then used this information to create new structure maps for each of the new layers. Porosity was copied into the new layers as well as permeability. We've now completely defined the geology of our system. Notice that the rest of the initial data need not be changed. The fluid properties, PVT, and relative perm data will be the same for our full field model as it was for our pattern model. This completes the initial data section. In the next section, we'll talk about the recurrent data for the full field model.